Okay, so as I just mentioned before I hit record, there were a couple changes to the numbers in your course information sheet, and I'm going to show you them now. This is the only real change, um, except for down below, I updated my office hours, which I'll show you in a minute. So you can see these numbers have very much changed because of the final exam. So we're following the rule that we had last semester that we did online, where the final won't be worth 50%. The college, and I agree with this, don't think it's fair to have a 50% final where you would be doing questions online. It's good and bad news maybe for you guys, but the idea is it's worth too much for one assignment or one assessment, I should say, online. So on Tuesday after our class, I had a meeting and they said I had to drop the final to 20, which means the other marks had to go up a little bit. So the other marks were actually 25 and 25, and you can see they've went up a bit. Now the labs themselves are worth 35, and we will only have 5 labs. Now, later in the year, we'll talk about this around the end of May, there will be kind of like a lab project, like a little assignment. It's very easy and very short, and we'll talk about that towards the end of the year. The big thing I want you guys to look at is the tests and quizzes. So there are no, assignments in this course. The labs themselves are similar to assignments. I'll give you some information. I might give you a video about the lab, maybe, for example, testing the amount of carbon dioxide in water. That's a lab we're going to do. So I might give you a video and then give you a week to do a little report on that video. And it sounds hard, it'll be really easy. You'll see it's just like your labs from Chemistry 1200 or 1201. You'll have basically fill in the blank, answer some questions about the information I give you. You can almost imagine like if you had the lab in 1200 or 1201, 1210, whatever you did, imagine if the instructor did the experiment and then you did the report. That's kind of what the labs will be. I will show you the water quality testing experiment, and then you guys will do the report. So that's your labs, and it's worth a good chunk, right? 35%. Now, the test and quizzes will be obviously on D2L, and they'll be very short online, through the D2L quiz software quizzes. It might be 5 questions, 5 multiple choice or 5 fill in the blank. Could be a little bigger once we get to chapter 2. But I just want to warn you guys, these tests and quizzes, we might have 4 or 5 of them because there's 4 chapters. So we might have, 1 in chapter 1, 1 in chapter 3, 1 in chapter 4. Chapter 2 might have a couple because chapter 2 is huge. So, plan for the future. Think about 5 or 6 quizzes, maybe 7, but not, nothing crazy. But they will all be very short, but they are worth a lot. The biggest mark from this course will come from these D2L quizzes. And like I said, they will be multiple choice, fill in the blank, true or false, very short and easy. But you want to come to class and you want to look at your notes because all of these quizzes will come from your notes. And again, it's worth 45% of your course. So if I had, say, 5 or 6 quizzes, they're 7-8% each. So they're worth a fair bit. Guys, these quizzes won't be a specific time, meaning I won't say you must do the quiz at 7:30 p.m. at night or it's closed. I'll give you a day to do the quiz or maybe 2 days. So it'll be pretty easy going, nothing too stressful for you because this is a stressful time. But again, I just want to warn you, the tests and quizzes on D2L are worth a lot. So make sure you don't miss any and make sure you try your best. Don't do them, without paying attention. Have your notes with you while you do these things. So we'll talk more about the tests and quizzes as we progress through the course. I'll probably have one from chapter 1, again, just a couple of questions based on what I'm about to teach you now. So I'm going to get started with our course, finally. I'll start obviously at the beginning, chapter 1. These are double classes, and we have them twice a week. So it'll be a bit of, a lot of information, I should say, thrown at you, but it should be okay. It shouldn't be too busy. So I will share my PowerPoint and we'll get started. I just gotta, Zoom is picky sometimes. Hold up. Okay, here we go. Excuse me. Hold on, guys. Okay. There we go. I got it. All right. So you guys should see this, see my PowerPoint here. Can everybody see this? Not everybody needs to tell me, but maybe someone in the chat can say this. Can you see this? My PowerPoint, it should say chemistry. Yeah. Okay, great. So Sophia, Nor, whoever else, thank you very much. Great. All right, let's get started. I'll stop rambling here now. So I made a pretty little slide here. This is my PowerPoint, Chemistry 2770. This is one of my favorite chemistry courses at the college. I have a little, I like saying this because the first time it happened last semester. Officially, as of last semester, I have taught every single chemistry course at the college. So like everything, there's a lot of them. So this is one of my favorites from the list of chemistry courses. It's different than your chemistry courses. It's not like 1200, it's not like 1201. It's more maybe like some of your environmental health and safety courses where it's just information. We're going to have discussions. I might show you some videos about chemistry and how it applies to the environment. I know that sounds a bit silly, but that's what it is. It's applied chemistry. So unit 1, guys, this is a really quick unit. I might finish it today. Very short. And I might go a little quick through this unit because the big unit is unit 2. Unit 2 is our most important unit. It's called water chemistry. It's about environmental health and safety around water. So I'll go a little quick through this today, and whatever I can get done, we'll get done. And then next week, we'll start unit 2. All right, so first section, definitions. Terminology is a fancy word for definitions. So the outcomes, we're going to define environment, we'll talk about what environmental chemistry is. Now, wink, wink, I know you guys can't see my face, and probably some of you have maybe never seen me before. If I wink or say the word wink, that's like me in class saying, you might want to know this part. So outcome 1.13, we're going to talk about different roles of environmental chemists. And it doesn't need to be a chemist. This could be anybody in environmental health and safety. Roles, so cleanup, monitoring, regulation, prevention, and research. That's really, really important. So hopefully I can get to that today. And then, the last outcome is stuff you learn when you were kids. What are some environmental concerns that affect human life? So, climate change, sea level rise, deforestation. There's so many easy answers to this question. Oil spills, things like that. All right, so first things first. You guys said this is not your first chemistry course. This is not a definition you need to know for this course, but before I define environmental chemistry, I'd like to define chemistry and define environment, and then we'll put it together. So chemistry, obviously the study of matter. That's it, okay? Physics kind of looks at energy and interactions with matter through energy, so speed and velocity and gravity. Chemistry is the study of matter, matter itself. the chemical composition, chemical properties, chemical structure, chemical reactions of matter. If you can't remember what matter is, this is anything that occupies space and has mass. Okay, so matter, could be a tree, could be a rock, could be water. That's matter. Sorry, guys, I haven't written in a couple weeks. I promise my handwriting is better than this. Environment. Okay, environment is the biotic and abiotic surroundings of a population, an organism. All right, now biotic, these are living things. Abiotic are non-living things. So if you think of where we live in the Middle East, okay, in Qatar or Doha, biotic things would be like the trees, okay, animals, birds, cockroaches, gross. I found one the other day, so hopefully there's not too many bugs around where you are. But anything living would be biotic, and that obviously includes plants and trees. Abiotic are non-living things. So sand, water, these are not living things. Rocks, right? I mean, none of these things are living, but all of these things make up the environment. And specifically in this course, we're going for abiotic, we're going to talk about water and air, and the biotic will be anything living. So humans, animals, whatever. So that's kind of where this course is going to go. We will look at the properties of water and air and how it affects us and animals and different creatures. And one little thing, you don't need to know this. So you should know this because I want you to know these two words, biotic and abiotic. But just one thing here, in science, the environment can be tiny, like microscopic, or maybe an easy example for you would be, think of an aquarium. That's not microscopic, but that would be a small environment. An aquarium, is something you have in your house with a couple fish in it. That is their environment, but it could also be global. So when you talk about things like climate change or trying to think of like global issues, sea level rise, climate change, the warming of water in general, these are global problems. But you look at something like deforestation, which is cutting down of trees, that's not really a problem in Qatar because there's not a lot of trees. But where I'm from, that is a big problem. And another word you guys might have learned is desertification. The growing of the deserts, that might be a problem in the Middle East. Not really a problem where I'm from, where there is no, we just have trees. So the environment can be tiny, like an aquarium in your house, or it can be, big, like the country of Canada or country of Qatar, or even bigger, like the whole world. These two terms you should know. They're not in your course outline, but you might hear me say the word biotic or abiotic. These two factors make up the environment as a whole. That's it. You don't really need to. This is just an excuse for me to make a fancy picture in PowerPoint. But, non-living and living things, put them together, that's your environment. Now, this is something you do need to know. It's in the course outline. Environmental chemistry. What is it? There's a lot of types of chemistry, guys. There's organic, there's physical, inorganic, analytical. There's tons of different branches of chemistry. And environmental would look at chemical and biochemical phenomena, or just things that occur in natural places. So, an analytical chemist might study this is a weird example, but maybe, I'm trying to think of something that's not necessarily related to the environment. An analytical chemist might, you watch CSI, they might study a crime scene. So they might look for, chemicals in a sample of blood or something like that. Or you might have a food scientist who looks at the amount of sodium in a packet of chips or crisps. Well, environmental chemists don't look at things like food or crime scenes, or they're not making pharmaceuticals like an organic chemist. They would study nature. So what would an oil spill do to, a water supply? Um, what chemical problems could arise from industrial waste into a river or stream, things like that. So, environmental chemistry is the study of sources, reactions, transporting effects, fates, meaning what would happen to chemical species in the air, soil, sand, water, everything around us. It also looks at and this is kind of where you guys might find jobs, where you might make your money. You guys, as environmental health and safety students, you would look at the human activity and biological activity on the above. So you might get a job for Qatar Petroleum or RasGas, and they might want to drill somewhere. And you might want to look at the impact on the mangroves in Qatar, or the impact on, the shoreline, the beach. I say beach, I mean like the coast of Qatar when you're, drilling and digging and things like that. So pretty interesting. The college, and I'll be honest with you, and maybe I shouldn't because I'm recording this on YouTube, but my background is pure chemistry / analytical chemistry. And when I went to university, that's kind of what I studied. I kind of studied all aspects of chemistry with a slight focus in analytics, meaning like when you guys did a titration, that's a good example of an analytic chemistry experiment. But the university I went to, their specialty, and it's the only university in my area that does this, is environmental science. So a lot of the schooling I did and the labs that I did were based in environmental chemistry because that's what my school specialized in. So it's really, really interesting topic. And I mean, the cool thing about environmental chemistry, guys, is it's worldwide. You look at problems in the desert, problems in the ocean, problems in the forest. It's worldwide. So this is something that applies no matter where you go. Meaning there's jobs everywhere. Well, inshallah, there's jobs for you guys everywhere because the environment surrounds all of us. So the environment could study chemical processes in the environment, and it typically, from a career point of view, would look at anthropogenic activities. Now, anthropogenic is a word I really want you guys to know what that means. You probably already know what that means. It means human caused. And this is becoming more and more important since I was younger. The importance of looking at human impacts on the environment. I think 50 years ago, if you wanted to dig for oil, it was like, yes, thumbs up, go dig, no problem, here's your money, do it. Now, if you want to cut down trees, you want to build a building, you want to dig for oil, you want to, do anything, there would be an environmental impact study, and you would look at sometimes the chemistry of this. The impacts, anthropogenic impacts, could be local or global. So the impacts could be just, urban, meaning, if you are building a brand new skyscraper in West Bay, that's not going to affect London, right? It's not going to affect Turkey, Istanbul. That would be a local impact. But when you look at, the drilling of oil or combustion of hydrocarbons, that's global. So, these impacts can be small. You can just look at a river, a lake, maybe, a shoreline, or it could be the whole world. All right, that's it. So environmental chemistry, the scientific study of chemical and biochemical processes in nature. Done. You might see that definition on a quiz, or you might have to fill in the blank or something like that. This is the big one. This is the one I really want to get to today and get through today, is the role of environmental chemists. Now, guys, this is a very broad topic. So I've personally narrowed this down to what I can find, and when I did the research, what I kind of simplified it into a few parts or a few roles. Obviously, this can be different in every job in every place in the world. So environmental chemists, they look at a range of concepts. They have a range of purposes when you're studying chemicals in the environment. From general chemistry, when you guys think about chemistry 1200 or 1210 or 1201, and you might say to yourself, what's the point? Why did we do that? You know, who cares about titrations and equilibrium? Well, all of these chemical reactions are, you know, have a role in nature. Chemical reactions like combustion, equilibrium, chemical equilibrium, you would see in a lot of natural environments. Solutions, for example, testing water, sampling, proper collection of samples. So like every time you weighed something or measured something or used a graduated cylinder, you are taking a sample and using an analytical technique. All of these things are involved in environmental chemistry. And, you know, some of you might work in a lab someday testing water samples, or some of you, you know, you might hear the term, there's contaminant in the water, you know, 100 ppm, parts per million. This is all chemistry. So we are going to look at, again, there's many roles, but I've narrowed it down to 5 major roles. So we're going to look at each of these. I'll check the time, and we might kind of finish after this. This is basically the end of chapter 1, guys. So if I can get through chapter 1, we're good for today. All right, so let's very quickly go through each of these. You are expected to know each of these, wink, wink. Remember, guys, all of your D2L quizzes are online, so you can have your notes with you, right? There are no closed book tests. You can use your notes. So you don't have to memorize any of this, but you should know where to find it and then what each of these things mean. So let's start. Now, cleanup and remediation, basically the same thing. Remediation is a big word for kind of a remedy of the problem. Remediation is a big word for cleanup. And I think I forgot to change my slide. I tried to use more plain English in my notes. So remediation is cleanup. Okay, one of the jobs of environmental chemists might simply be cleanup. Something happened. It's too late to go back. You can't go back in time. You can't stop the oil spill, or a truck tips over on the highway and spills oil or toxic chemicals everywhere. It's too late to change that. But then how do we remediate that? Meaning, how do we fix it? Well, environmental chemists might look at the sources of the pollutant. So where did it come from? You know, if it's an oil spill, it's easy. It came from the ship that spilled the oil. But it might be an unknown source, like there could be a leak in a pipe, or there could be, some illegal dumping, illegal people throwing out waste illegally. Where is the pollutant coming from? Then looking at chemistry theories to get rid of the harmful substances. Now, guys, when it comes to oil spills, a lot of that is mostly scooping it up. Like it's not so much chemical as it is physical removal. But sometimes, like you think about a swimming pool, okay? If the pH, the acidity or basicity of your swimming pool is off, it can be dangerous to your skin, or maybe it can, be hazardous to your health, because if the pH isn't right, it could grow bacteria. So you can use chemical theory to get rid of that. You can change the pH, for example. You could neutralize an acid or neutralize a base. So through chemical theories, chemical reactions, you can get rid of harmful substances. And sometimes your job might just be an advisor. You might use your chemical theories to talk to the government or other institutions, other industries about how you would clean up this process. So that's cleanup, right? You can find the source, apply chemistry to get rid of that pollutant, or you could just simply be an advisor and tell other people what you would do. Monitoring now, this is a big one. From my experience in industry and talking to students, I know I have a lot of students that work in oil and gas. I have a lot of friends in Canada that work in oil and gas. I'm using that as an example because it's so, it is the big industry here. Monitoring is extremely important. I mean, one of the big ones. Again, I could use a swimming pool as an example. If you go to a hotel, or maybe if you guys live in an apartment or a compound, somebody monitors that swimming pool in theory, right? I hope. They're testing things like pH and chlorine levels maybe, to make sure that it's clean and it has the proper chemical makeup of a clean swimming pool. Well, change that to industry, you might collect samples of a water supply. So Qatar is a little different than other countries. Qatar, I know we desalinate ocean water, but I can guarantee you somebody in that plant, that factory where they desalinate the water, is collecting and analyzing samples of that water to make sure it's clean, right? Where I'm from, it's a little different. The water is natural. Not saying Qatar's is natural, but what I mean is when I was young, the water just came from a source of water. It was almost untreated. So we didn't desalinate. There was very little treatment. And there's something we're going to talk about a little later in this course in the water quality section. There's a bacteria virus, I don't know the proper term, but it's called Giardia, and we used to call it beaver fever. And it sounds really weird, but the idea is animals, their waste was going into my water supply, and when it got so bad, we used to have to boil our water. I have something in the chat. Parasite. Yes, you're correct. Thank you, Nora. I'm not a biologist. I'm a chemist. So thank you. And Giardia is, we would call it beaver fever. I don't know why. Well, I have an idea, but it was something in the water from animals, from nature, that would pollute our water supply. These parasites would go in the water supply, and people could get very sick. The side effects of Giardia, and I can speak from my father because my father got this when I was very young, is, nausea, diarrhea, can be very serious. And somebody in my city, their job was to continuously collect and analyze water samples all the time. And if they found Giardia or any other parasite in the water, we would get what was called a boil order, meaning you could, like, imagine right now in Qatar, somebody said you can only drink bottled water. We would have something similar. But in the 90s, we didn't have bottled water, not really. So we would have to boil our water, like, in the kettle or on the stove. Anyways, I'm kind of rambling, but monitoring is such an important environmental chemical process, because this is how you catch a problem before it gets serious. So you monitor water, you would monitor air. I know in oil and gas, they constantly monitor H2S, hydrogen sulfide, which is a toxic poison gas. And this is a byproduct of oil refining or oil extraction, and very toxic. So this gas is constantly monitored. I'll talk a little bit more about this in chapter 2, but monitoring is incredibly important. So somebody monitoring chemicals, you would observe contaminations, look at pollution potential, meaning is there a potential for this to, turn toxic, become a pollutant, and provide ongoing, all the time, technical advice looking at disposal and treatment. Monitoring is something that occurs before, during, and after any type of industrial or chemical process. You would monitor it before you do it, while you're doing it, and then after you're doing it. I mean, this monitoring is the big one. Regulation, this is not my favorite one, right? This is the government stuff. So this is, the legal stuff, not my specialty. My specialty would be, the chemical side of it. But regulations, you might deal with the government, and you guys probably have courses on this, but every government has its own specific regulations. And later in this course, I'm going to look at American versus Qatari regulations. I choose American because it's all publicly available. It's very easy to find. And then the Qatari regulations. Every country has its own regulations. So you might deal with them to make sure that the water quality has a certain amount of, or a small amount of lead, but that amount is regulated by the government. So it might be 50 ppm here, it might be 20 ppm there. You would advise on safety and emergency responses to issues, meaning you might be the environmental or occupational health and safety person at a refinery, for example, and you would advise on emergency response if a pipe breaks. People involved in regulation are often employed by the government or industry to make sure that regulations are being met. Are you following the law? Because again, I know in Qatar, it can be very bad. If you don't follow government regulations, you can be fined very heavily, right? You know what I mean by fine. So they might charge a company 10,000, 50,000, 100,000 reals if they don't follow regulations. You guys are environmental health and safety, but you can think of food health and safety. When the government, I think it's the Ministry of Interior, the MOI, they put out all those notices about restaurants that are being closed for not following, food safety guidelines. That's kind of what an environmental chemistry would do, or environmental chemist would do. But instead of food, it would be, water or air quality. Prevention is very similar to monitoring, but to me, monitoring means you're watching. So you're constantly analyzing samples before, during, and after some, industrial process. Prevention would be developing the program in case something happens, or if you know something's going to happen, how can we prevent that from happening? So developing a preventative environmental chemist might look at remediation programs. How can we clean up this problem before we even start it? They might change production processes to be more environmentally friendly. How can we use less plastic? How can we use less oil? Maybe you guys think about renewable energy. So maybe we could use solar instead of burning oil. Maybe we could use glass or a recyclable material instead of a one-time use plastic, things like that. And then, of course, any preventative chemist would look at safety issues and then emergency response. What we want to prevent this from happening, and if it does happen, this is what we do. This is pretty easy stuff, guys, and especially because you can use your notes. So I'll go a little faster here, and then we can clue up for today. The other thing, guys, I'll mention, this is a boring chapter. I'm kind of trying to get through it. I promise you and I know I said this last class as well, but I promise when we get to chapter 2, we can start getting a little bit more, it'll be a bit more interesting, and there'll be a bit more chemistry and room for discussion. So I'm just kind of trying to get chapter 1 out of the way so we can start the big chapter. All right, so research, and then there's one more section I'll do. We might finish this, we might not, but let me do research. I'll get into the next section, and that'll be it. Research. So this is kind of the stuff I like. If you were a research environmental chemist, like it says, you would do research. So you might not be working with a specific industry, or you might not be, monitoring water supply from, say, the desalination plant, but you might be in a lab looking at research. Without environmental research, we wouldn't really know how to fix some of these problems that I've been talking about. So environmental chemistry looks at understanding first, what does the natural environment look like? So, you look at the mangroves off the coast of Qatar. What are they normally like? What chemicals are there? What are present naturally? Think of it like when you're doing an experiment? What are your initial observations? What does this environment look like naturally? And then you would research what might happen with humans, what their impact would be with the excuse me, release of chemicals. It doesn't even need to be chemicals too, guys. It could be even temperature changes. So like you talk about thermal pollution, that could cause very, very big problems, chemical or biological problems, just by changing the temperature of water. So a lot of courses you've done at the college and a lot of people researching in university looks at natural chemical processes and then looks at what we would do as humans, how we could affect that process, how we would change that natural process. One of the things we'll talk about in chapter 2, and something that a lot of people don't think about when they think about climate change, is so climate change, we're talking about temperatures going up, water temperature, air temperature. One interesting thing that you don't see a lot on the internet or in the news is the effect of carbon dioxide and pH. And this is kind of where research could come in. You look at things like the coral reefs in Australia and fish biology. These reefs, these fish, they need to live in a specific standard pH. You take an aquarium in your house. If that aquarium gets too acidic or too basic, your fish will die. You can test it. Please don't test it. Keep your fish alive. But I mean, it is known that a change in pH can drastically change the chemistry, and then the living can harm the living creatures in that water supply. And one thing we'll talk about in chapter 2 is the CO2 that we're putting in the air from burning hydrocarbons. That's an acid. And when it mixes with water, it forms H2CO3, carbonic acid, which is an acid, obviously, which is lowering the pH. And these are things that researchers are looking at. How do these changes in pH, like why are they killing the coral reefs, the Great Barrier Reef in Australia? What's happening to salmon off the coast of Canada when we're lowering the pH of the water? So, people in labs kind of research this stuff. So anyways, I'm kind of done with that. I know I rambled a little bit. I wish I was in class with you because it's a little bit more entertaining. But you want to know these at least 5 roles. So remediation, how do we clean up a spill? How do we clean up a environmental problem? Monitoring, studying the chemistry of, a source, could be air, soil, water, before, during, and after some human activity. Regulation, this is following the laws of the government. So you might look at, making sure the industry is following the laws, coming up with plans for the government if there is a problem. Regulation is kind of like your legal part of all this. Prevention, very similar to monitoring and remediation, but prevention would look at, okay, if this happens, what do we do? And then research, of course, this is kind of your overall encompassing research. You might study the effect of climate on penguins in Antarctica. You might study the effect of rising sea levels on Qatar. You might study the effect of, it's very general, pH on the Great Barrier Reef, things like that. Okay. I know this is boring. I'm kind of looking forward to chapter 2. So guys, it's 10 after 2. If this was only one class, we would obviously be done, but I would like to do a little bit of this. Just let me see how long this is. Okay, let's finish this. This is really short. If you guys give me 5-10 minutes, we can be out of here. And before I get into the next section, I hope you're all alive. I haven't bored you to death. Is this okay? Is everybody all right? Do you have any questions on any of those environmental chemistry jobs or roles? Or do you want me to, you good? I can move on. And for me, okay. Guys, thank you. Perfect. I got I wish I could see you guys. I don't even know what you look like. This is so weird. But yeah, so Noor, Sophia, Fatima, Rawa, Raunak, Hiba, everybody, thank you. One thing I'll mention too, at any time, literally any time, ask me a question in that chat. You don't have to worry about interrupting me. If I'm in the middle of a sentence, I can finish. So just, yeah, keep chatting if you have any questions. All right. Oh, and I have a question for you actually before I do this. Does anybody have class after this? Or is this the end of everybody's day? Does any, oh, you guys got class? No. Okay, end of the week for some, class for some. Okay. I always like to know if I'm the last class of the day, because that kind of means, I don't know. I always feel good being the last class if I end early. But if you guys got class after me, I guess it doesn't matter. Okay, anyways, 3 quick outcomes, guys. Give me a couple minutes, 5-10 minutes tops. I mean, this is stuff you learned when you were kids, or young adults. I know I did. I mean, I like to pretend I'm not that old. I say that every year, but I keep getting older for some reason. But think of me as a 90s kid, if that puts my age into perspective. And, in the 90s, we learned about the 3 R's. What was it? Reuse, recycle. Oh my gosh, I can't remember all the 3 R's. But when I was a kid, we would talk about the environment all the time. And not so much about the new things, like it's not that new, but I don't remember hearing a lot about climate, but I remember hearing a lot about picking up your trash, not throwing certain things away. A lot of this stuff is common sense, and you probably learned about this in school. So we're going to look at the industry's responsibility, sources of pollution, and then ways you can reduce pollution. And guys, I want to stress something here. There is no one answer to this. If I asked you, wink, wink, to list a way industry might reduce pollution, just because it's not in my notes doesn't mean it's not true. If you learned about something in another course, if you know something because of your experience, you've read something, you've seen a documentary, you've worked somewhere, there is no one answer. These are just some that I've picked. All right. So I love it when you guys do this. It's called thinking outside the box. Don't feel that you need to answer from my notes. Be creative. If you know something that I haven't mentioned in my notes, put it down, because this is such a broad topic that I can't put everything on 1 or 5 slides. So, be creative. I love it. I love to see creative answers. All right, so industry and the environment. A couple of examples of environmental impact from industry. Some of these are, I've known about, and I can see in my backyard from being a kid. Some of these are over hundreds of thousands of years. Well, I shouldn't say thousands. That's not, I'm talking about industry. So hundreds of years of industry. So climate change. This is a good example of something that is happening over hundreds of years. Not as easy as something like, say, deforestation or pollution. And there's one I should add here, guys. And I don't know if I'm going to spell this right, but one I could add here is desertification, kind of like the growing of the desert. So anyways, that's one maybe more local. So yeah, climate change. This is you guys have heard about this, I know, a million times, the rise of global temperatures based on, could be natural processes. The temperature of the earth is cyclic in a sense, but then also anthropogenic issues. So things like burning fossil fuels. And I guess that would be our main culprit there. Deforestation, this is a problem I can see in my own backyard, literally in Canada. Not so much a problem now. It's done with very much, government regulations. Environmental chemists and biologists study this all the time. We do something called selective cutting, but deforestation would be cutting down the forest, as easy as that sounds. And I know you read in the news about the Amazon forest, in South America. That's a big problem. You're removing an ecosystem. The animals can't live. You're drastically affecting an ecosystem when you cut down trees. Desertification, that's another one. That's related to climate change or related to industry. That's the growing of the desert. Um, you guys know the desert, not hospitable to plant growth. Farming, it's very difficult in the desert, and as that grows, you're again affecting the ecosystem of things, humans, animals, plants. Depletion of the ozone layer, this is an interesting one. From my own kind of research of this, the ozone layer, this was an issue when I was a kid in the 90s. We've actually, I don't want to say fixed this, but this is something you guys might not have heard about, or you don't hear about a lot. This is something in the 90s I heard about all the time. There's chemicals that humans were releasing into the environment. CFCs were one of them. Think of like aerosol sprays. So like hairspray, there's many examples, but like spray paint, hairspray. There were certain chemicals humans were releasing that were depleting the ozone layer. And you can think of the ozone layer like sunscreen for the earth. So protecting us from UV rays. And from what I've read, is the ozone layer has and is continuously repairing itself. So this is not as much as an issue for you as it was when I was a 12-year-old kid in the 90s. I remember hearing about this all the time. But that was a human-led issue that we have since fixed from environmental science. Yay. Pollution, I mean, what a broad term that is. Pollution could be anything. I mean, just littering, throwing your garbage away, oil spills, air quality pollution. So, again, combustion of hydrocarbons. Pollution is just a worldwide problem. And then extinction of species. That's another big environmental impact. And the extinction of species, guys, can come from all of these things. If you cut down the rainforest, where are these animals going to live, or habitat? Where will their habitat be? So all these problems are related to industry, and they can cause extinction of species. Not good. Almost done. So industries, for us as environmental scientists or chemists or health and safety people, when you're talking about regulations, governments regulate industry, and globally, we feel industries have a responsibility to protect the environment. This was different 100 years ago. 100 years ago, it was just like, yes, do it, build it, burn it, destroy it, tear it down, doesn't matter. It's not the same in 2020. So industries have a responsibility to protect the environment. They must follow the environmental laws from the government. Industries can receive help and guidance from other organizations. So, Qatar Petroleum, RasGas, these companies might hire outside people to help them monitor and prevent issues that come from drilling for oil. And industries are generally, from what I've seen in my life, becoming more proactive in environmental management. Regulations globally are becoming more strict. You hear about a lot of countries trying to become more green. We're really trying in a lot of places to get rid of coal. I know Scotland and Germany are two good examples of countries really trying to get rid of coal and move to wind or geothermal, other types of energy. Sources of pollution, guys, there's a million answers to this, a million answers. You guys, if I asked you a source of pollution in industry, be creative. Tell me something I don't know or I don't have here. These are just a few that I have. An accidental spill. Could be human error, right? Somebody forgets to do something, close a valve, check the pressure, a pipe breaks, human error. Could be from transporting, an oil spill in the ocean, a truck tips over. One we'll talk about in the last unit is a good one, improper storage. You know, you have chemical waste from a hospital, you know, biochemical waste, and you're not storing it properly and it gets into a water supply. Very dangerous. Another one, now I know these are similar, but a spill is an accident. Discharging contaminants can be intentional, meaning you're just releasing it because government doesn't have regulations. So to start discharging contaminants into the air, land, or water, think of your car, your whatever you drive. You know, it's discharging constantly contaminants into the air. Either of those two are just examples, and they can be from poor management or relaxed government regulations. All right, we'll talk a bit more about this later. One more slide and I'm done for today. When you look at pollution in industry, reducing it is obviously the goal, and there's a few ways to do this. One way is quite simply redeveloping a product. So using more environmentally friendly materials, maybe it would be, have you guys heard of biodegradable? I'm sure you have. Sorry, my pen always does this little weird jumpy thing. All right, so think about a company using biodegradable materials. So if, you know, it does get thrown away, it will degrade, meaning break down naturally very quickly. You could change the production processes. So the chemical on site can be produced differently. Maybe you're making something cleaner, more safer. You could produce it on site. So instead of shipping oil across, you know, a country to be refined, you could refine it on site. That's a big issue, guys, with oil and gas, is a lot of countries, Canada is a big one, the place that they dig the oil is not where the oil is refined. Some of the oil in Canada is sent to Texas. Now, I don't know if you guys are familiar with geography, but the oil is from northern Alberta. So just think of like North America, think of like the top left part, and then it goes to the bottom right. Well, the bottom kind of center, that's where Texas is. So, you know, if you can, you know, instead of shipping these toxic materials, produce them on site, it'd solve a lot of problems. And then, of course, you can be creative and find different ways to solve waste problems. So again, recycling your waste or maybe reducing your waste. So these are all just examples of ways industry can reduce pollution. And if I ask you to tell me a way that industry can reduce pollution, feel free to be creative. All right, you don't have to, like, I don't want answers that are like cut and paste from my slides. I'd like something in your own words, or maybe something I don't have here. Okay, cool. Is that the end of chapter 1? Yeah, it is. So guys, that's basically it for chapter 1. That is not what the other chapters are like. Okay, chapter 2, just let me show you. So this is chapter 1, 23 slides. Okay, let's have a look at chapter 2. And I'm done. I just want to show you what's coming up for the next like month. We will totally do this for the next month. So chapter 2. Chapter 1 was 23 slides. Chapter 2, guys, is 187 slides. Chapter 2 is basically your entire course. Chapter 3 and chapter 4 we can do in a class, but this is a giant chapter. And this is where we're going to get into chemistry. We're going to talk about density and polarity and things you learned in 1200. Okay, so I'm done for today. Sorry if that was a little bit boring. I promise next day I'll open it up for some questions. I'll make it a little more interactive, a little more entertaining. So I'm going to hit stop record. And if you have any questions, you can ask me right now. If you have no questions, have a great weekend. And I'll see you next week. No lab on Sunday.